Today we're going to review some familiar topics. We're going to be talking about gradients and equations of lines. So for the first half, you guys are going to be able to find the gradient of a line and of 2 points. And when we get to equations of lines, you will be able to write the equation of a line, which hopefully you guys remember from Algebra 1 or geometry. Okay? So let's start off. Gradient, that's the vertical change over the horizontal change. Very familiar, right? Gradient is another word for what, you think? Slope. Yes, it is. Okay? Gradient is used instead of the word slope and is represented still by the letter M. X. M? M, yes. Okay. What's the formula for slope? Y2 minus Y1 all over X2 minus X1. That is the change of your Y's over the change of your X's. Okay? The dozen symbol does mean change. Shorthand for change. I'm not going to write out that whole word. Okay? Is this formula in your reference book? Yes. Yes, it is. So, gradient, it represents the rate of change and should be written as a fraction or in simplest form. Okay? When you guys did slope before, you never wrote it as a decimal, did you? No. You always went it as a fraction so that way you knew how far up or how far down you went and how far left or right you went, right? So it should be written as a fraction and in simplest form. Okay, so make sure you reduce that fraction. If you haven't found the slope and it's 8 over 4, reduce that to 2 over 1, which is just 2. Okay? Now let's review some old stuff. Who remembers? The gradient of a horizontal line is what? Horizontal line. That's slope. That's what it's equation, but yes, it is 0. Think about it. Slope is how much you change, whether you go up or down, right? If it's a flat line, are you doing either of those things? No. So the slope of a horizontal line is always 0. What about a vertical line? On that one would have some type of an incline. 0. No, 0 is horizontal. Talking about vertical. It's undefined. Yes, but think about it. If you jump off a vertical cliff, you will be undefined. Okay? There we go. Yes, the gradient of a vertical line is undefined. Okay? Y'all remember this? Coming back? We dusting off the math knowledge a little bit. What about parallel lines? What do you remember about parallel lines? 2 lines that are parallel. Say what? They have the parallel lines have the same slope against the 3 lines. Yes. So the slope of one line is 2, then this parallel line will also have a slope of 2. However, perpendicular lines have what? Opposite what? Opposite, yes, but opposite something else. 3 lines. Opposite is one of those words. Then there's another word. No. Intercepts. It slopes. We know that perpendicular lines intersect to form a what? Rusty. Oh, ooh. It is. Oh, I know it is. Because once someone says it, it's going to come back to you guys. Perpendicular lines, they intersect to form what types of angles right here? A right angle. So if this slope was a slope of 2, this slope would have to be what? No, because 2 would mean it would be parallel. The same slope. Close. That's the opposite part. Starts with an R. Yes, there we go. Opposite reciprocal. Opposite reciprocal. So to go back to that example, if I have a slope of 2, then the slope of its perpendicular line is going to be, -1 over 2. Okay, opposite reciprocal, and the third word will be slope. I need to actually start using the proper word. So let me not use slope, let me actually use gradient. Because when the problem says find the gradient of the line, you want to make sure that you know that gradient means slope. Okay? Oh, Rusty. Okay? Lesson 1. We're going to try to start you guys off easy. Okay? So, that's all the basics you need to remember about gradients. Let's do a little bit of work here. All right? We're going to find the gradient of the line that passes through those 2 points. Okay? Well, I have 2 points. I should use what to find the gradient of it? The formula. Okay? So it's y2 minus y1 over x2 minus x1. What's y2? Negative 2 minus y1, which is 4, all over x2, which is minus x1, which is 2. Okay? Good stuff. Negative 2 minus 4 is, and negative 1 minus 2 is, when you divide a negative by a negative, you get a what? Wonderful. And what's 6 divided by 3? Awesome. So the slope of this line, or the gradient of this line is 2. The gradient of this line is 2. That's how you do it using the formula when you're given 2 points. What if you're actually given a graph, though? We can do it the same way. We can figure out what this point is here. We can figure out what this point is here and use the formula again. Or, what's another way besides using the formula to find the gradient? Okay. Rise over run. So basically try to figure out how far we go up or down to get from one point to the next, right? Do I rise or do I fall to get from point 1 to point 2? I fall. How far do I fall? 2. So this right here, the y technically would be a negative 2. The changes of my y, because I went down 2. And then what? Right, how many? Okay, so it's down 2, right 7. Anytime you run to the right, it's positive. If you ran to the left, it would have been negative. So then it would be 7. So my slope would be negative 2 over 7. Question? Okay.
How do you know which point to start with?
Well, in this particular case, since those 2 points were highlighted, you'll want to use those. If it weren't highlighted, it's always better to find a point that falls like on the intersection of a.
No, I mean, like, how did you know, like, to start with that point instead of this one?
Oh. Okay. Well, the reason why I started with the far left point is just like in a book, we read from left to right, correct? So it's a little bit easier. If we wanted to start with this point, we would do the same thing. Okay, to get from this point to this point, don't we have to go up, right? So we'll go up 2, and then to the left 7. And remember, if you go to the left, it will be negative. So it's still a negative 2 over 7. It doesn't matter whether the rise or the rise or the fall is negative or the run is negative. At the end of the day, if any part of that fraction is negative, the entire fraction is negative. Okay? Good question. That's question. Pretty easy. Mm-hmm. Yeah, I can give you the homework. You need to go. Maybe. Okay. All right, let's look at number 3. What is the gradient of the line parallel to L? Anyone? The same thing. So it's going to be what? Negative 2 over 7. Because remember, parallel lines have the what? Have what? The same gradient. What about the gradient of a line that's perpendicular to L? I take a volunteer on this one. What's that? 7 over 2. It is the opposite, which means it goes from negative to positive, and then you reciprocal it, which means you flip it. So it becomes 7 over 2. So far, so good? Okay. Now, let's draw, this is not a part of this, let's do a little extra here, okay? Let's draw, using this graph, a line perpendicular to L that passes through the point 2, 4. Okay? We're going to draw a line that is perpendicular to L that passes through the point 2, 4, using this graph here. We're going to use this graph here. Well, to draw the line that is perpendicular to L that passes through the point 2, 4, I probably want to do what? Put the point 2, 4 in. Everybody remember how to plot points, right? Okay. So I start from 0. Excuse me. I start from 0, 0. I go over 2, up 4, 4. And if I wanted to graph the line that's perpendicular to L that passes through that point, what should I do? We use the gradient that's perpendicular. Exactly. We found out what the point was, or what the gradient was for the line that's perpendicular to L, so now we just need to use it. And we have a starting point, which is 2, 4. Now, my only issue is the 7 over 2 means I need to go up or down? Up 7 and which way? Right. To the right 2. But if I do that, I'm going to go out of this lovely little grid that I have. So now, how can I get a point that's on the other side? Go down 7, so 1, 2, 3, 4, 5, 6, 7, and then go left 2. Wonderful. And so when we draw this line, and I'm going to cheat, I'm going to use this feature here. Nope, I'm still off. Okay. When I use this feature, I'm now able to graph a line that does form a 90-degree angle at that point. Remember, perpendicular lines always form 90-degree angles. Questions? Can't wait till we get the hard stuff. I really feel like, Ready? Gradient intercept form. What does gradient stand for? Slope. So really it's saying what slope intercept form. Say, what slope intercept form? Okay. Not minus, but plus. And what you always know, IB is going to shake your world. It's not MX plus B in the IB world, it's MX plus C. Okay? So this right here, C is the new B, okay? And the reason for that is because when the other forms there are to write a line, that B is significant in a different form, okay? So it's MX plus C. C is still your what? C is still your y-intercept, and M, of course, is your slope. A gradient. Hold me accountable. It is your gradient. What about point gradient form? I helped you out a little bit to start you off. It's y minus y1 equals, very good, M x minus x1. Where x1 and y1 represent what? What do x1 and y1 represent? One of the points. And then, of course, the gradient is, okay, so the gradient is M, the y-intercept is C, okay? Now, there's one more form that's not on here. I want you to add it on because it is one of IB's favorite ways to ask you how to write a line, okay? And that is the third way. What's the third way? Anybody remember? I heard someone say it. That's what it is. Yes, standard form. It is standard form, okay? But they don't really call it standard form. They just say write it in this particular form. And that is AX plus BY plus D equals 0, okay? Where A, B, and D represent the coefficients, and when you deal with them as a ratio, they can represent your slope or your y-intercept. We don't worry about that. We'll get more into detail with the examples that we do when we get to the equation notes, but I do want to make sure you guys also have down this form, okay? Yes? I'll post the video. All right? So Those are your different forms. Let's take a look at this one. What is the gradient of PQ? I want you guys to find the gradient of PQ. Do that now. Find the gradient of PQ. Okay, so who has the gradient for PQ? Eric. Sorry.
1/3.
It is going to be 1/3. Okay, what was it before you reduced it? 2/6. Yes, you could have done it from the actual line itself, went up 2 and to the right 6, or you could have used the formula using the coordinates for P and the coordinates for Q. Now, granted, you needed to write the equation for PQ in point gradient form, so you needed one of those points to do it. Can I get a volunteer to give me what they got? Hey. Okay, so you used P. Okay, so P was the point -2, +1, and yes, plug it to the formula. Very nice. Now you're asked to find what is the midpoint of PQ, and I gave you the formula here. Does anybody still have their reference book out to tell me whether or not that formula is in the reference booklet as well? It would be probably under prior knowledge. So yes, it is. The midpoint formula is there. Okay, it's not given to you on the SAT or ACT, so you will need to know it for those. Okay, and who can give me the midpoint? Shani. 1, 2. 1, 2. Very nice. Okay. Q was at the point 4, 3. So you just add your x's, divide by 2, and add your y's and divide by 2. Very nice. Questions? Now we have to write the equation for the perpendicular bisector of PQ in point gradient form. A lot of words in that. Okay? But these are the two key words that you need. Perpendicular bisector. Take it back to your geometry days. We kind of already talked about one of these words. Perpendicular means what? Forms a 90-degree angle, which means the slope of this perpendicular bisector is going to be what? The opposite reciprocal. So perpendicular, and this is symbol for perpendicular, is upside down T, if you've forgotten that. I need the opposite reciprocal gradient. And what does bisector mean? It splits it in half, okay? Now, if it splits this segment in half, that means it has to be cutting through the what? Through the midpoint. So in order to write the equation of the perpendicular bisector, you need the opposite reciprocal slope of the line PQ, for the segment PQ, which is what? What's the opposite reciprocal slope of PQ? -3/1, so -3. And you'll need a point. The point is going to be your midpoint. Did everybody catch that? To write the equation for your perpendicular bisector, you need the perpendicular slope of the segment, which is -3, and you need the point of the midpoint because that's what's going to cause it to cut in half. Now I'm able to write this in point gradient form. So that's y minus 2 equals -3 x minus 1. Questions? Before we go on to number 9, I'm going to ask you, for number 8, if I wanted you to write it in gradient intercept form, and you already have it in point gradient form, how do I get it to the other one? How do I get to the other form? What would I need to do? Solve for y. To solve for y, I need to distribute the what? Distribute the -3. So that'll give me y minus 2 equals -3 plus 3. And add the 2 to the other side. So then I'll have y equals -3x plus Careful. Plus 5. And now I've gone from point gradient form over here in the orange to gradient intercept form in the pink. And so now I can actually answer number 9 very easily. It says ST is the perpendicular bisector of PQ, aka the equation we just found. What is the C? What's the value of C for ST? It's 5. Okay. 5 is the intercept, the y-intercept of the line. And since we have found the equation for the perpendicular bisector, which was this right here in the orange, then we were able to convert it into gradient intercept form to find that y-intercept. Okay? Now, does anybody know another way we could have gone about doing this instead of writing it in point gradient form and then converting it? Is there a way I can go just straight to gradient intercept form? Does anybody remember that way? How to go straight to that y equals mx plus c form? Graphing it, that's an option. Does it, anybody, what if I didn't ask you to write it in point gradient form first and then convert it? How can I go just straight to this equation? Y equals mx plus c. We had our gradient, didn't we? What was our gradient? 1/3 was for PQ, but for the perpendicular bisector it was what? -3. So we had our slope, right? Didn't we have a point as well? What was the point? 1, 2. So don't forget, another way you could do is you can actually plug in the values for x and y using that point. Plug in 1 for x and 2 for y, and then solve for c. Don't forget, that's the other way that you can do it. Okay? So 2 equals -3 plus c, add 3, and 5 equals c. Don't forget, that's another way. And then we'll have y equals -3 x plus 5. Coming back to you? Okay? To be honest, your geometry teachers taught you how to do this way before showing you point gradient form. Okay? You know how I know? Because all my students last year did it this way instead of going the other way. How are you? Yes.
Can you select over number 8, please?
Number 8. Yes. The writing of the equation?
Yes, come on.
Okay. So there are 3 different ways that you can write the equation of line. I would never encourage you to write it in standard form. Ever. Okay? Because there's no way that you can go just straight to standard form. Alright? You gotta go one of the other 2 forms into that one. The easiest way to write the equation of a line is point gradient form. Point form. Okay? Because you only need 2 things. You need a point and a slope. And if they make you find those 2 things beforehand, then you just plug into the formula and you're done. No simplifying needed, nothing like that. So we use point gradient form. All we need are those 2 pieces. We just need our slope and we just need our point. Now, I asked you to find the equation for a line perpendicular, or find the gradient for the line that was perpendicular to it in what, 5 or 6? And so then you get the -3. Then I asked you to find the midpoint, which you got to be 1, 2. Okay? And to write the equation of the perpendicular bisector, which is a line that is perpendicular.
Oh, we use the midpoint for the y?
Because in order for it to be the bisector, it has to go through the midpoint. So then all we do from there is just plug in. Y minus 2 equals -3, x minus 1. And that's how we got the equation. So what are some real world applications where we can use gradient? Okay? Real world applications. Architectural design. That's a lot to write. Okay, and I have to spell it right. R. So it's close. Architecture design. I teach math, not English. Okay, architecture design. Anything else? Yes. Water slides. Yes. Water slides, or shoot, even just the basic old school slide. Yes. Mountains. Say again. Driving. Maybe going down a hill, driving up the mountain. You can combine those together. I'll take one more. The raw is like, if you jump off a cliff, you too will be undefined.
Yeah.
Base jumping, right? Base jumping. For all you thrill seekers out there. Okay, there's infinitely many places where slope is involved. Okay? So if you ever wonder, well, where am I ever going to use this? Okay? Now, granted, base jumping is one of those just like natural phenomena and people just find, like, it's not like someone created that cliff. Okay, that's just natural. All right, but water slides, anything that deals with architecture, mountains are still natural as well. But maybe a hiker, might need to determine those types of things. Okay? When will we see this again? Well, we'll see this in functions. Okay? We'll see this in functions when we get to that unit, which is going to come after this one. You're also going to see it in derivatives, which is calculus. Okay? You'll see this again. And actually, you'll see it at the end of this unit in Bernoulli diagrams. Okay? I'm going to write that one out. Because I want to make sure you guys can spell it right. That's right. I did spell it. Okay? Bernoulli diagrams. I think you guys will enjoy those, though. It's different. It's a different way of thinking about design. Look at me being this simple. All right. Questions about grading? Functions, Bernoulli diagrams. And calculus. You say calculus. There we go. We're going to look at our pink foldable, the one that has equations of lines. I want you already kind of be creative. Go ahead and get the goal down for this one, okay? Again, refreshing your memory about how to write the equation of lines. We're going to be looking at this more IB-based, though, okay? Give you some more IB worded types of problems, okay? So then that way, you start getting a little more comfortable. Start getting a little bit more comfortable. All right, so we've already talked about the 3 different ways to write the equation of a line, okay? You have point gradient form and gradient intercept form. You have standard form, okay? So now we're actually going to use those, and we're going to look at some of these examples, okay? This is all strictly examples of using these things, okay? We'll do the first one together, and then I kind of want to see if I can just let you go after that, all right? You have the line L passes through the point A, 1, 7. That's the first one, right? Passes through the point 1, 7 and has a gradient of 5. Find the equation of L and give your answer in the form of y equals mx plus c. How do I do this? Huh? We have the gradient, so plug it in. Okay, so if I plug in the gradient, I now have y equals 5x plus c. What's missing to write it in the form of y equals mx plus c? I need the c, so I need to plug in what, Robert?
1 and 7 for y and x.
1 and 7 for y and x. So I'm going to plug in 7 for y, 1 for x, because that will help me find my c straight on, right? 5 times 1 is, anyone? 5. How do I solve for c? Subtract 5, so c equals 2. Now, this is where students tend to lose points in the IB question. Why? Because they stop there and they forget that they're supposed to do what? Plug 2 back into the actual form. Like you find the c, and then you just forget that you actually are supposed to find the equation, okay? So make sure that you always go back and read the question to make sure that you actually are answering it completely. So y equals 5x plus 2. Easy peasy, lemon squeeze. We proceed. I think we're at all. All right. I want you guys to try this, okay? I'll give you about 3 minutes, and then I'll check in to see your status, okay? You can work together. Let's do some practice. Fractions will happen. Ugly decimals will happen. Your time of nice numbers has come and gone. Come and gone. Okay. So, line L has a gradient 1/3 and passes through the point 2, -1. Did we use the plugging in method to get the C to get the equation? Yes? Yes, maybe? Okay. So, -1 for Y. We'll go over here. -1 for Y equals 1/3, 2 for X, and let's find that C. Everyone knows how to multiply fractions? Okay? You know, all you do is put that over 1, multiply straight across. That's -1 equals 2/3 plus C. Then we subtract 2/3. Okay? So that becomes a -1 and 2/3 equals C. How do I turn that into an improper fraction? 3 times -1 and then add the 2, and what is that? 5/3. That's your C. So I have Y equals 1/3 X minus 5/3. Yep. Even though those are nice fractions, they're actually very pretty. They're pretty fractions. Okay. That's it. We okay? All right. Now, B and C help you in finding D. It even says that. This is a write down the point of intersection of L with the y-axis. In other words, what is the y-intercept? It's a write down problem. Now, write down doesn't mean to write the letter C. Okay? It actually means that there's very little to no work needed to answer this question. If you did A right, your answer should be staring you smack dab in the face of what that intersection is with the y-axis. Okay? But it is a point. Okay? It is a point, so I should have the parentheses with the comma. And if it's if it's an intersection with the y-axis, that means my x-coordinate is always what? 0. And what's my y? -5/3. Anytime you see a write down, that should be an indication that, oh my goodness, I don't need to do much of anything. Okay? You'll see that a lot. But in C, it says find the points of intersection of L with the x-axis. Find means I'm going to probably have to do a little bit more. How do I find an x-intercept? The easiest way. What formula? If anybody has a different idea, I mean, you can shout that out too. Yes? Could. We're dealing with some fractions here. So that means if I try to graph it, it might not be spot on. We're looking for the spot on point. We don't know for sure if that. Well, we need another point to do that. We don't have another point. If we have an x-intercept, then we know automatically that in that point. So we know one of the coordinates already. The y-coordinate is what? 0. So couldn't we use that and the gradient intercept form to find the x-point? Plug in 0 for y. Anytime we're looking for an x-coordinate, we can plug in 0 for y. Anytime. And that doesn't go with just these lines. It goes with quadratics, cubics, rationals, radicals, all those. Okay? So let's solve this. How do I solve for x? What do I need to do? Add 5/3. And when I divide by 1/3, I'm technically doing what? Multiplying by the reciprocal. So what is that? 15/3, which is 5. So now I have my y-intercept, my x-intercept, and I can draw the line L using that information. So I'm going to go to 5, 0. I'm going to go to negative 5/3 and 0, or 0, negative 5/3, which is in between negative 1 and 2. And I'm going to draw my line. Any questions? Oh, let's see again. Questions? Let's be really good at this. There we go. To the next one. Okay. So for this one, it says the line L1 has the equation of 2x minus y plus 6 equals 0. This is in standard form. So it's asking me to write down the gradient of L1 and the y-intercept of L1, which means I probably want to make sure that it's not in standard form, but in gradient intercept form. Okay? To go from standard form to gradient intercept form, I probably want to write probably want to solve for y, right? Now look at some of y'all's paper. Some of y'all subtract 6, subtract 2x, and divide it by negative 1. That's all well and good. An easier way would be to do what? Move the y over. Move it by itself. So then you would have 2x plus 6 equals y, which is adding a y, and then it's there. Okay? So what's the gradient of L1? 2, and the y-intercept? 6. Okay. You have the equation in gradient intercept form, and they give you a point A. If a point lies on that line, that means you can plug in that x value and that y value, and it should make a true statement. So when it's like this, you no longer have like your c, like an actual physical variable of c. So don't let this wording right here throw you off. C is just a variable that's holding the place for the x coordinate of this point. So how do I find c? What do I need to do? Plug in what? The 1.5 in for y, and what for x? Maybe c, because that's what I'm looking for. Subtract 6. What's 1.5 minus 6? 4.5. Divide both sides by 2. What is c? 2.25. Okay? So there's your value of c, 2.25. Now it says the point B, 5t, lies on L1. Find the value of t. Same thing, right? Except this time I'm plugging 5 in for what? X, and I'm solving for t. That's a y. What's 2 times 5? Plus 6. So t equals 16. Questions? L2 is parallel to L1. Parallel lines have what kind of gradients? So L2's gradient is 2. And I'm looking for the equation for L2 if it passes through C, which is 0, 4. 0, 4 is the what? It is the y-intercept. It's the point for the y-intercept. So I don't need to go through the plugging in of 0 for x and 4 for y and solving for c, because basically it's going to give me c right away. So y equals what? 2x plus 1. Parallel lines have the same slope, different y-intercept. Same gradient. Questions? Okay. Right here. These little lines, powerful notes. Because if we have parallel lines, our slopes are going to be the same. So the slope for L1 we found was 2, so that means the slope for L2 is going to be 2. I was here?
No, from 2 times 5 plus 3 equals c. I don't know if that thing next to b is.
Oh, this is a 6.
Oh, okay.
Yeah. So this is 6, and it equals t. So I used this point, and I plugged in t for y and 5 for x into this equation. So I use this one. So, no, listen, it's okay. You gotta let me know. My sixes do look like B's. I apologize. I try to write my B's like this, and then my sixes like this. So, like the gabbage. All right. Let's see. I think we got this class of 57. Let's do this one together. All right. So we have a line that joins the 2 points, and we need to find the equation of L1. Well, I have 2 points, so I need to find the slope. So that's going to be y2 minus y1 all over x2 minus x1. 6 minus 2 is 1 minus 1 is. So my gradient is -2. Now I'm given a point, and it doesn't specify how I should write this, so why not leave it in point gradient form? So I'm going to use point A, and I'm going to write it in that form. So that's y minus 2 equals -2, x minus 1 is the easiest way. Now it says that C is the point 10, -16, and we have to decide whether A, B, and C are collinear, given a reason for our answer. Now remember, anytime it asks you to provide a reason doesn't mean you need a full, long paragraph explaining why these points are collinear. It really is more about the math that justifies yes or no. Okay? So, if all 3 of these points are on the same line, and we use A and B to get the equation, to determine if they're collinear, I need to plug in the point C for x and y. If I get the left side equaling the right side, then that means it's a point on that line. And if it's a point on that line, that means they're all collinear. That's what collinear means. All the points lie on the same line. So, to determine and to provide reasoning, I'm going to show my work of plugging in -16 for y and 10 for x to see if the left side does indeed equal the right side. Question? Here? Yeah, this is a point for point. This is -18, -2 times 9. What's -2 times 9? So because the left side equals the right side, yes, these are collinear. And the word justifies the fact that it's on that line. There is a true statement. Okay? So from this, we talked about how to find the gradient and how to write your equations of lines. All right?